Section 2.6 limits at infinity, horizontal asymptotes. We have the function y equal x squared minus 1 divided by x squared plus 1. To wrap this function, we just make a lot of points. And if we pay attention to the x part, when x is really large number or really small number, then the y part is very close to 1. So then the graph of the function is in the blue color, and you can see that it's very far away, that x is really positive or negative. The y part is close to 1. So in definition number 1 and number 2 below, we break this into two intervals. The first one is from the right side, and the second one is from the left side of the function. Definition number 1 saying that let f be a function defined on some interval from a to infinity, then the limit of f of x as x approaches to infinity equal to L means that the values of f of x can be made arbitrarily close to L by requiring x to be sufficiently large. So in this definition, it means that if you look at the x is really large, positive large, then the y part, the outcome, the output close to L. Definition number 2, let f be a function defined on some interval from negative infinity to positive a, then the limit as x approaches to negative infinity of f of x equal to L means that the values of f of x can be made arbitrarily close to L by requiring x to be sufficiently large negative. When x really large but negative, that means x is on this side, we can see that the y part close to L. Combine definition number 1 and definition number 2, we are saying that y equal to L is the horizontal asymptote. We have two conditions, either limit of f of x as x approaches to infinity, or limit of f of x as x approaches to negative infinity equal to L. Then we say y equal to L is the horizontal asymptote. We have number specifically in this problem. Go back to this problem, and we can see that x approaches to positive infinity, the function f of x or y approaches to 1. And x approaches to negative infinity, the function approaches to 1. So conclusion, y equal 1 is the horizontal asymptote. We have another example for horizontal asymptote. Let's look at the function tangent inverse. So when you have x approach to negative infinity of the tangent inverse of x, so negative infinity is here. When x approaches to negative, x is very small. The y is very close to negative pi over 2. Then we say y equal negative pi over 2 is the horizontal asymptote. And when x really large number, so let's look at this point. This is x really large and y close to pi over 2. Then we can say that y equal pi over 2 is the horizontal asymptote. Example number 1. So let's practice with the idea of horizontal asymptote. Find the infinite limits at infinity and asymptotes for the function f, whose graph is shown below. So in this problem, there are 3 parts. Number 1 is that they're asking us to find the infinite limits. Infinite limit, that means we find the limit of the function f of x as x approach to some number, can be on the right side, can be on the left side of that number, give us the answer is infinity. And it's either positive infinity or negative infinity. Okay, so let's look at this point and this point right here. This point right here is -1. So you can see that, right here, right? So if we can say if x approach to -1, and you can see that in the both side, +1 or -1. So in this side, okay, the function go to positive infinity. So recall the definition of the vertical asymptote. What do we say? X equal -1 is a vertical asymptote, because the problem also asks us to find the asymptote also. Okay, so we have learned the vertical asymptote in the section before. And now let's look at 2. If I find the limit of the function f of x as x approach to the left side of 2, and limit of the function f of x when x approach to the right side of 2, left side of 2 give me negative, right side of 2 give me positive. So for both definition of the vertical asymptote, we can say that x equal to 2 is a vertical asymptote. So go back to that section and review the definition of the vertical asymptote. Okay. Now the other part of the problem is that the limits at infinity. The limit at infinity, that means we find the limit when x approach to positive infinity, and the limit of the function as x approach to negative infinity. So look at the x when it's go to very far away on the right side, which is positive infinity. So let's look at this point. Then what can we say is that the y part approach to 4, right? And when x go to negative infinity, approach to negative infinity, the y part. So let's look at this point, approach to 2. So we can say that y equal to 4 is the horizontal asymptote by definition of the horizontal asymptote. And y equal to 2 is a horizontal asymptote.